in, but that you could also have some IP ownership. So that was the inception of Basics. I then flew to Ethiopia with Ben, and I met the gentleman that will be on this call today from ICOG. When I met those developers over 2 years ago, I realized that I was in the room of a bunch of really special people. That these young people like yourselves that come out of college having a desire to build something bigger than them and to solve a lot of their local problems. I made a promise to them that we would build something together and that we would travel the world teaching people and helping people like yourselves bring it together. Now, we've done hackathons in Kenya, we've done hackathons in India. We worked with the guys at Hack India about a year and a half ago, and we decided to kind of push out on our own. If any of you guys are following AGI or SingularityNet, you'll see that they just had a really big event in San Francisco yesterday, and there's also a large consortium of hackathons that are happening all over the world. The difference is we're looking to make sure that not only we build things, but that you build things that can actually take you into, let's say, a go to market opportunity. Maybe you build something that might be a solution for farming. Maybe you build something that is a wallet. You build an AI agent that you can put on the market. Whatever it is, just another hackathon. Said to students, hey, we're going to get you certificates. We also were let down with some of the blockchains that we partnered with that did not come through with the thing. Continue to move forward. We continue to see of the Kenya for aligning. I also want to thank the St. Joseph's Institute of Technology for inviting their students yet again to participate. And I also want to thank my team. So over the next 4 weeks,
Uh, Sorry, Neff, I think we're losing you. You're cutting off.
to be making sure that you guys not only haven't had a chance to see some of the last screen shares from our last incubator. You can go to the beyondthecode.ai on YouTube. New incubator is Omega Fall.
On, which would be which would be at the around September. The dates will be announced for you guys. So before the hackathon, we need you guys to be able to a little bit of understanding, to have a little bit understanding of Meta, because the hackathon is going to be conducting using Meta. We're going to be having two cohorts or two levels starting from next week. So that will be decided by you guys. You can pick whatever level you feel more comfortable with, and we can then try to preserve your choices as much as possible and also see your skill levels, which is why it's very important you guys fill out the forms we've been sending around the Telegram and WhatsApp, and also shared with you via email. So one of the tracks is going to be Pure Meta, the other one is going to be Omega Claw, or the agentic AI. So for that, I'm going to give you a bit of a brief introduction today, but if you want to proceed with this track or with the Omega Cloud track, we expect a little bit more from you guys. So make sure to try and catch yourselves up with the Meta tutorials and resources, as we're going to be starting straight from the setup and other related stuff to this one starting from next week. But if you decide to go with the normal Meta track, then you can follow along with us starting from next week, because we're going to be giving you guys tutorials and some example projects that you can actually take inspirations from for the hackathon. But in either case, we really encourage you guys to go through the resources. We have a lot of videos, a lot of resources, example exercises that you guys can take a look at, practice, which will help you with whichever track you guys will be joining on. So yeah, just wanted to tell you that. All right. So during any of the training, please feel free to interrupt and ask any questions. But I'll also be giving you guys time toward the end for you if you have any questions, so you can ask and clear any confusions you might have. Okay. I think let me quickly share my screen and we can start with today's presentation.
Yes, so before you start, yeah, may we please request the students to share their school or organization on the chat so that we can acknowledge also your school and institution. So thank you, everyone.
All right. I guess not to repeat what she said, but yeah, it would be good if you guys can send some introduction in the chat, get to know to each other, because as you all know, since the end goal is going to be a hackathon, it would be good to get to know other people that you can work with early from this incubator. So feel free to chat in the here in the meeting, also in Telegram, and also we'll really appreciate it if you can turn your videos on. But no worries if you guys are camera shy. Okay. Can everyone see my screen? Can you give me a thumbs up? All right, cool. So to begin with, Omega Claw is basically an agentic AI framework. So if you guys are familiar with the recent agentic applications or agentic frameworks that have been going around, you might have heard something like OpenClaw or some other frameworks like Hermes, or they're pretty much diverse agentic AI frameworks out there right now, especially those who are open source. So the most famous one and the most pioneer one that got public the first was the OpenClaw. So if you're familiar with it, the basic idea is basically to give an LLM some form of like access to the environment via several tool calls, several skills, and different kinds of like tools that will be available for it, so that it becomes more powerful. So it's basically like beefing up your LLM so that it can do more than it was set out to do. And the main advantage of that was that you can actually use any type of LLM with any type of tools or any types of like environments, and communicate with it with not necessarily via a web interface only, but with any type of like communication media you would like. So it's basically a framework that decouples all of these integrated systems, which we were only limited to before. So, for example, if one of you guys wanted to use ChatGPT now, the most easiest way is just to go to their website and chat it there. But if someone wants to set it up on Telegram, if you want to chat with it on WhatsApp, that's going to be a bit difficult for you. So when that means this AI LLM ChatGPT is very coupled with its platform. So that is one issue these kind of agentic platforms frameworks were trying to solve. So when you decouple the communication channel from the AI agent from the tools it has access to, it basically gives you a versatility that you guys have never seen before. So this is just to give you a sense of what an agentic AI framework can provide you with. So, and generally, we'll try also to see how Omega Claw integrates those features and also how it's different from the other frameworks. Okay, so as I tried to mention at the beginning, this LLM or this Omega Claw framework is basically a very powerful language model like ChatGPT or Claude or any of the open source models, which is wrapped in parts you can actually utilize, inspect, edit, modify, or add, extend, such and such and so. So that what that gives you is basically it gives additional capabilities for your LLM. So if you want your AI model to search the web, for example, you can do that by adding a functionality that searches the web. If you want your agent to do something specific, for example, I don't know, set up a calendar for you when you chat with via Telegram or via voice command, for example, then you can use these kinds of frameworks and multiple modules. It could be a voice to text module, it could be normal natural language module, and additional tools that have access to your Google Calendar or whatever calendar you guys use. And then that language module can perform the action you want it to perform. So the possibilities are quite endless. You can think of anything that is digital and try to automate it using some kind of like agentic platform. So very interesting stuff. So this is what the framework generalizes. These kinds of implementations kind existed already. So even before these famous OpenClaw or other agentic frameworks, there were some kind of like approach to try and work around this kind of problems because the possibility was just very attractive that people were already experimenting with it. But it's on OpenClaw that the first that we are very aware of, which managed to integrate everything seamlessly into a single framework where everyone can use it for any use case. But here, Omega Claw is something similar to that. It has additional capabilities rather than just interacting with you in a natural language. It has its own memory, it can have its own reasoning system, and it can have also its own way of reaching out to you, which means it's not necessarily tied to a single web interface. You can set up your AI model or your agent on a separate server, and you can access it via Telegram, Discord, or WhatsApp, all share the same underlying memory tools and everything. So that decoupling like gives you access to multiple platforms, and it's not only you that can interact with your agent. You can also give other people access to your agent. For example, if you can create some kind of group or channel, then you can add your agent to that channel, and everybody can chat with it, and it can interact with humans. It can see the content that you guys are giving it around there. So it's very helpful. So when we come to Omega Claw, it has specifically around, it has a lot of moving parts, but we can generalize them into 7 components. And around the 7 components, we have 6 of them already built. One of them is still under development. Not to say that the other implemented ones are also perfect, but at least we have a working version for them integrated into this agentic framework. So we're going to see them one by one. So the first one is something called the space. So for people who come from who are completely new to Meta, this terminology might be a bit weird for you guys, but we have this form of database or memory in Meta, which is called an atom space, or you can just refer to as a space. So it's just a form of database, a way of storing information which you can get access to. So in Meta, what makes this space a bit unique is that you can store any type of things inside it using the same representation. So either you're writing some kind of code or either you're writing some kind of data. It could be a graph. It could be a normal like data types like booleans, numbers, or it could be any long lists, for example. Any types of data structure you want to store in this database or in this memory, you can store them in a unified manner. And we will see why that's very effective here. So the Omega Claw, since it's meta-based implementation, meta-based framework, it has this built-in feature basically because it's built on top of Meta, so it has everything it uses inside its space. So everything we mentioned earlier, every tools that your AI model has access to, every configuration you're setting it on, every logic your model needs to follow or your agent needs to follow before executing something, all live inside this space. So that is very powerful because you don't have to deal with a lot of configurations in files that are very scattered. You don't need to define a specific framework for defining how the memory of the agent should work. You don't have to basically like write a separate file, if you want to change the logic of this AI model or this AI agent, everything lives in a single unified place called the space. So that's one of the things that separates it from other agents, and this make it very easy to extend and add new, for example, tools. Framework is that the Omega Cloud framework is that we have this we have something called loop. So this loop is basically like agent that will call your it benefits you to give you a comparison. For example, it always expects you to send some kind of message before it can respond to you. So they always operate in a way of like query, response, and they don't really initiate anything by themselves. So you can kind of get around this limitation by setting up some kind of loop that iterates over a specific set of instructions that you designed, which we'll go over in a bit, and then use that loop in order to like give the autonomy to the agent so that it can reach out to you via whatever channel you set up. So it can ask you questions on its own. It can give you summary of a research you told it to do a while ago, or it can do a lot of interesting stuff using only this loop. It can also like ping you in a topic that it found interesting that it was doing on its own. It doesn't necessarily need you to give it a specific message or specific question to respond to you. It can basically like use its context, memory, everything it has been learning so far to come up with something interesting and ping you about the findings it has. So this loop has around, we can like generalize in around 4 steps. It tries to look around its memory, what's there, what's in my memory, what has the user asked about recently, or any other relevant context, what kind of tools, what kind of capabilities do I have. It asks this information in the first stage, and then once it collects everything, it can then go ahead and decide what the next action should be. So if there is something that misses priority, if there is a user who is asking a question, if there was a very interesting topic the user found intriguing, something like that, it needs to decide on the second stage. This decision will be made by the AI agent itself, the LLM in this case. The lookup will be you providing some of the additional context you have to the LLM or to the agent. Then once the decision is made, you act on that decision, which could be triggering a certain tool or triggering a certain like a certain capability. It could be searching the web. It could be like adding a date to your calendar. It could be whatever related thing that the LLM needs to do. Whatever it needs to do, it needs to decide. Then it needs to go and act. After the action, it needs to remember what the result was or what it found, or even just remember basically what you guys interacted about. So this remember, we'll go over it in detail in just a moment, but it basically stores it basically like stores different information on different levels. And we'll go over it, I think later, that's better. So the other advantage of the loop is when nobody is talking to it, it can go in silent, because one of the biggest issues with running an LLM in a continuous loop is token costs. So to cut on those token costs, if nobody is talking with it, it usually tends to wind down and sleep, and after with a timer, of course. Then after the timer is set and triggered, it will wake up and perform some actions and check some things it needs to check and go back to sleep again. But if there is a user in the chat that can interact with its message, that can keep interacting with the agent, and the agent keeps going. And yeah, the last one would be like, if it in case it made a mistake, then since there is a loop, it doesn't just tell you the mistake and stop its iteration. It will just keep iterating until it finds a solution or it runs out of your required budgets. So in a nutshell, this loop will allow this agent to keep working even if after you have sent your message or after it has responded to your first message. So this loop will allow the agent to gives it some kind of autonomy, and it kind of like gives you a realistic version of how you interact with the agent, because most of the time it's when you interact with an agent, it's either like a message and response, and it's never the other way around. The agent doesn't really ask you a question on its own or interact with you at the initiate a conversation on its own. So that leaping over that will give you a very high benefit, or maybe a very high like thrill about like how to use agents to feel closer to humans. So the third one is going to be the channels. So for the channels, I tried to mention this earlier. We have a lot of multiple channels here. So it could be a Telegram channel, it could be a WhatsApp channel, it could be a simple web interface. Whatever you want the agent to deliver its communication with, get its responses from, is going to be your chosen channel. So it can even be a Discord channel. So it's generic implementation. But the current Omega Claw implementation has around three channels: the web IRC interface, the Telegram interface, and I think the Matter message. It's something like Slack. So you can have this kind of interface so that the agent can interact with you and be the same as you are. And yeah, because of the loop we have, it can also message you whatever channel you picked. So it could be on Telegram, it can message you there. If it is on WhatsApp, it can message you there. All right. So the fourth one is going to be the tools. So as I was trying to say from the beginning, I kept mentioning this thing called tools and tools. So what are tools? So basically, a tool is a very short and explicit like capability an agent has. It's a written code basically. So if, for example, you want the agent to search something on the web, then you have to do that by giving it right. So as I was saying, the tools are basically something that you can reuse a reusable piece of code. So basically, if you want to search a web, then you write a certain program that can query the web, search via an API call, then you can respond that, return that, and give it as an output to as an input to the agent. Okay, sorry for that. So the other example could be, for example, if you want your agent to perform a Google Calendar setup, that would be one other tool call that you can use so that you can interact with your calendar in a way that is not bound by the LLMs like environment that is working right at the moment. All right. So the main benefit of like having this tool is basically the main benefit of the tools we have here in Omega is basically you have a very short list of these tools. So you will not get lost in a very nested chain of tools where you don't know which tools are being called or which tools are doing what, and that could be a very risky thing for security wise, especially. But when you come to the Omega Claw, you only have like a very short list of tools. And in case you wanted to extend that to fit your specific domain, then there's this concept called dynamic skills or dynamic tools, which you can load skills depending on what you're doing. Those skills can also be written by you. It can be using Meta, it can be using Python, run multiple things depending on your specific use case. So that should cover everything about tools. And let's come to more sophisticated part of Omega Claw, which is the memory. So memories are a bit tricky. Memories are a bit tricky because like the LLM has a very limited context window. You can't just it has been so you have a constraint in that regard. Most currently state of the art AI model quickly that can fill up. So for that, we have the Omega Cloud framework has this decomposed into three layers. The first one is the working memory. The second one is story, or we can call it in a more technical term as episodic memory. The last one is the long-term memory. So for a working memory, this is basically a very short memory, short-lived memory, which you store your tool results or the direct message you gave it to, or the last previous result discovered. It's basically short-lived. It has a very high like character limit, but it's basically short-lived. Once your churn increases, then this working memory disappears, or you can clear it out. So after the first step, or after it gets used once, then you basically can get rid of this working memory, because we want the next tools or the next tool call, the next message to replace it. The second one is the episodic, or the story layer. So here you have like a sliding window like based memory, basically built into the system. So this is also a long-term memory, but it is going to be storing everything it has seen, every tool call, every interaction with humans, and a very big meta file, which is going to be loaded in the space as necessary. So this will be needed for log entries, for example. It can be used by the agent to search for the history to find some interesting things based on timestamps or based on some keywords. It can match based on some kind of tool call structures and so like so. That is possible, but at almost every time it's going to be a sliding window of like preserving only the last K important interaction or important memory entries. The last one is going to be our long-term memory. Here, the agent decides what needs to be preserved long-term, what is important that needs to be stored as for a long-term. So to do that, it's going to be using some external data, which is not going to be only the meta space. It's because we need to store some vector embeddings or semantic information, which we will cover in the next sessions if you guys are not familiar with it. But if you are, it's basically a way of like representing text in a numerical form so that you can run similarity search later on, basically to identify what kind of like to identify meaningfully similar terminologies or phrases, or basically anything that can be encoded in this form, and then retrieve it and give it back to the LLM. And you can also like add additional context to it. You can add timestamps, for example. You can also have other metadata information for it, but this is going to be a limited list because we can't have this very big because it can corrupt the memory a bit. But the agent also like can select what needs to be stored. For example, if you tell it to remember a certain thing, it will explicitly store it in its long-term memory, and this long-term memory can be accessed whenever it needs to remember something. And it's not going to be, of course, given to the agent every time, but whenever the agent needs to access this long-term memory, just as humans take a little bit more time to remember something, we can also use that here. And remember, we can ask the agent to remember something, and you can search this kind of thing over its long-term memory. So everything is decided by the agent except for these two. Actually, the long-term memory is decided by the agent. These two are kind of programmatic, and they have a moving window or an expiry date for the memories. But this can help the agent remember things better. All right, so the last and most interesting part that is currently working is its reasoning. So most of the agents we know so far, they don't have an explicit way of reasoning that we are aware of. So what I mean by reasoning is, for example, humans, we tend to follow some uh, logical construct that can help us basically like verify whether our claim is correct, whether our conclusion is correct, whether something could be true or false. It's our way of like deciding whether something is actually true or false. Actually, that's a good summary. But most LLMs don't have this capability. I mean, they have it to a certain extent, but when your reasoning gets a bit complex, then they tend to make a lot of mistakes, and they have no way of catching whether that thing is actually a mistake or not. So they don't have a deterministic arithmetic way of like finding how things can be corrected, or if things how true things are, how false things are, whether things are even true, or what kind of correct conclusion can you reach based on the current information, for example? This is very challenging stuff for LLMs, which is part of the reason why we can't use pure LLMs in different safety critical domains. But here we have a separate build component called null or PLN, which we'll cover if we have time in the upcoming cohorts, which is basically a deterministic way of like a deterministic algorithm that can give you an estimate of how likely something is to happen based on some information you give it in the beginning. So we'll see an example of it in a bit, but what it helps the agent to do is identify how likely something is to happen. So if it's not 100% sure, it can give it an estimate saying, well, this is actually 72% correct, or it can say, well, this is actually 25% correct, or even like 0.1% correct. Like it can never be zero, or it can never be 100, because depending on the evidence, some things can be vague, but it can give the agent an estimate of how likely something is to happen. And it can help the agent compound more complex reasonings without actually losing this probabilistic way of reasoning about things. So that helps the agent a lot because it can escape certain pitfalls that current agents have. So this is just an introduction, so I'm not going to go deeper than this, but if you're interested, you still can take a look how this is actually built. So to give you an example, an agent can observe something like this. So whenever you give it, it can give it a rule saying, well, anything that eats elephant is actually dangerous, and you can give it a percentage of 90%. Well, anything that eats elephant, I'm 90% sure that it is actually dangerous, and it is dangerous. Then you can say, well, tigers actually eat elephants. So what is the valid conclusion from this? This seems a simple example. So the actual result would be, well, tigers are actually dangerous because we have this rule that says anything that eats elephants is dangerous. So it's the main value is not the conclusion alone, it's the calculation of these percentages here. So whenever it gives you a result, it gives you like a percentage value associated with it, which is calculated based on the percentage value of your inputs, basically. So why would this percentage help us? What's the benefit of assigning these additional numbers? So to answer that, you can see this environment as an incomplete environment. So this stands on an assumption that you can never reach 100% certainty on something, because as soon as you introduce a new premise or a new input, then your perception might change. For example, here we're saying tigers are dangerous. So whenever you say tiger run, might be the conclusion we reach at. But that's not 100% of the time true, right? Because whenever you go to the zoo, you don't see the tigers as dangerous because they're locked behind bars, right? So that lowers their danger level a little bit down so that you can feel safer. So this kind of additional context gives you like different percentage values, and this is where the agents actually suffer a lot because they don't have a way of giving you a very structured and determined percents for these kind of reasons. So yeah, this is one of the other benefits of Omega Claw. All right, so just to give you how the loop might work at the top level, you can think of it like, well, whenever we start, we first need to search what we know. So we give it a supply of memory. So if we go back to the memory state, we see that there is working memory and story, and even the long-term memory is something that we keep around. So the agent can start by searching its memory, what it knows. So it can be for whether you interacted with it, or it could be on its own in one of its own iterations without your interference, but it needs to search what it knows first. Then after that, it can also search for what it can do, its abilities, its skills. It can search its skills on the space and see what it can do. Then it also searches for if there is anything that has changed. Because remember, if the users are interacting with the agent needs to give the users priority and respond, or maybe go over the messages that have been going around in the channel that it has been added to and find a conclusion or jump on a topic that it found interesting. And it can also decide whether it needs to do reasoning or not, and actually do perform certain reasoning before it responds. And then basically it iterates in this loop over and over until either the loop ends or the user interrupts it or something like that. So basically, once it goes through these steps, it will find some goals, it will identify something that it needs to do and perform those goals. It can update some things that it needs to or can perform a task. Very big, I understand, but you can tailor it to your context and understand it better. So if our task, for example, was basically to set a calendar, if there was a conversation in the channel that says, well, some person might be discussing about a certain event, then the agent might go ahead and set that event's date on the calendar on its own without being told to do so. Or maybe the user also can tell it not to set it on its calendar, and it can jump it over because yeah, sometimes that can be a bit problematic getting the agent without actually giving any other control. So the seventh pillar that is not yet working in the Omega Club, but is very interesting, is a motivation context. So currently, the way we manage goal is a very simplistic way of managing goal. We basically give the agent everything it can access, and then let's decide what it finds interesting and pick a goal on its own. But that's a bit fragile way of uh, setting a goal and motivation for the agent. So we can make this part of the Omega Cloud framework more robust by actually adding a more structured way of motivation system. So this system, when it's built, will basically guide the agent on what to focus on, and basically would become the interest or the motivation, the crux of the agent itself. So this motivation separate component can help guide the agent into what it needs to focus on right now, what it needs to be pursuing on its own, and it will add on the autonomous nature of the agent itself. So it will basically solidify the way it sets goals, it tracks goals, and it's autonomous. And yeah, it could be a very interesting implementation, something that we haven't seen in most of the agents, but it's also the one that's the hardest to integrate. So which is why to not integrated it, but it's under development and you can find it very right. So basically, these are the main pillars of our framework. What you might find Omega Claw separate from other agentic frameworks. As I tried to mention before, the first thing is that it does not stop. So it is a continuous loop that keeps running and keeps setting on its own goals. It tries to be more autonomous than the other agents out there. You can also, the other benefit is that you can also read the whole thing in a single file in a very small, the whole thing that guides this system is a very small piece of code that you can finish reading in a few minutes. It's just a single file under 200 lines of code. And the mind of this agent is actually as an Opal file you can actually look at your convenience. So the memory files I mentioned earlier, excluding the vector embeddings, all of them are available to you. So you can go through and see what the agent has done. And so this gives you transparency. Other agents, they're a bit hidden where what they're logging their information. So this is very useful in case you want some transparency of what the agent is doing. And the last one is that its confidence is like deterministic. It's not just guessed by the LLM. You can have reasoning engine integrated and make sure that certain things are actually true before proceeding. So that is a very interesting distinguishing feature of Omega Claw. So it's still at an experiment stage. So you might find some things as not fluid as they are, but this is why building a community really helps because it has a lot of potential for you guys to contribute and or come up with your own different version of Omega Flow to improve and make this thing fully production ready. But the team is actually working on it. We already have few deployed, and we can actually use that. And we already have certain users that have been actively testing this platform, and they are very fascinated by the agent. All right, so one possible future extension is that adding more symbolic components. So the one example of a symbolic component or some algorithm that does certain things deterministically is the reasoning component we mentioned a while ago. So that reasoning component is actually a symbolic reasoning component, which builds on the LLM agent so that you guys can find a more deterministic conclusions in certain goals in certain areas. But that's not the only symbolic component you can add. You can have a more deterministic way or more like a structured way of setting goals and drives for the agent. As I tried to mention on the motivation section, you can have a way of like organizing memories, times, and events. You can have a team over its own memory and like come up with unique ideas. And also you can make it plan a long-term planning and different things using symbolic structure. So these all things have their own part, which is currently under research and development, but these are a possible and potential future integrations. So yeah, that's pretty much it for an introductory level. We'll keep giving you guys introduction if you like, keep giving you guys a more deeper classes on this topic as we move forward. If you guys choose the Omega Cloud track, for those of you who choose Omega Cloud track. But if you still have questions that you would like to get answered before we run out of time, I would like to give you guys some time. So if there is anyone who has some question or something you guys need to be clarified, to be clear on, I think you guys can feel free to raise your hand and actually ask. We have around 4 minutes before we leave this session. So, any questions?
There's one
So,
question on the chat.
yeah, I just saw it. It is also accessible via WhatsApp. I think the link is not shared here yet, but if you guys can fill the form that is here, we can get a hold of you and add you on the WhatsApp as well. But we will really appreciate if you guys use Telegram because most of our community is already there. So just to reminder for all of you, if you guys want to go with the incubator, whichever track you pick, please fill the forms first so that we can know which of you are fit to go with the Omega coach track and which of you also can go with the Meta track. So yeah, filling out the form is actually mandatory. Okay.